computers need to store information, like the letter A or the number 27. Now, when they first tried to make computers, they were like mechanical machines, and they would try and store things by, for example, stacking up a bunch of rings on a spindle. Say, oh, look, I have the number 5 because I have 5 rings on my spindle. But when they made computers electronic, they found they couldn't find any way to do that. All they could do was create switches, electronic switches, which means computers have a switch that has an up position or a down position, just like a light switch. A little light switch, and a light switch has an up position and a down position. You could think of it as on or off, or in computer terminology, 0 or 1. That's it. That's all a computer can store, 0 or 1. So when we talk about computer memory, you may often hear the term memory, or you may hear RAM. And RAM, we'll talk about exactly what this means in a little bit, but RAM stands for Random Access Memory. Oops, spelled that one wrong. Random Access Memory. All it is a long series of zeros and ones. So if we have a long series of nothing but zeros and ones in our RAM, in our random access memory, how can we get the letter A or the number 27 into the computer? Well, the answer is a bit of tricky math. It's actually a math trick that they came up with. And the math trick works like this. So the math trick works like this. When we write a number, and you hopefully have learned this in math by now, and if not, it's not that complicated, we'll do it right now. Let's say we write a number 1,000, oops, wrong color, 1,241. Okay? You may have learned that these have different decimal positions, where you say, this is the tens place. You are correct. This is the one. Right. Correct. This is the ones place. This is the tens place. This is the hundreds place. And this is the thousands place. So what we're really saying is whatever digit we write in this position, if we multiply it by 1, in this case that would be 1 times 1, that's how we determine what the value is. And if we take this second one, and we say that we're going to write this as 4 times 10, we get our 40. And same thing here for the third position. If we write here that this is 2 times 100, so the value of this position is 200, right? Mm-hmm. Clear. However, there's another way to write these same things. If instead of writing the ones position, the tens position, and the hundreds and thousands, there's another mathematical way of representing it, which you may have seen, which is called an exponent. And in the case of an exponent, we write it like this. And we say instead that the ones position is 10 to the first power. And the tens position is 10 to the second power. This is 10 to the third power. And this is 10 to the fourth power. Right? You've seen that before? Great. Excellent. So what does 10 to the second power mean? It actually means 10 times 10. And 10 to the third power, it means 10 times 10 times 10, right? 10 to the fourth power, and so on. Great. Okay, you can understand that. Not too complicated. It's a very useful way if you're writing really big numbers. If you need to write a number with like 8 zeros after it, it's very convenient to sit there and say, I want to write 10 to the 12th power. I need 12 zeros after something. Very convenient way of writing numbers. Okay? Great. But I said computers will only store numbers as ones or zeros. What do I mean by ones or zeros? As I said, I have a physical switch. I have not computer language, I have a physical electronic switch. And the switch can either be up or down. Literally, there's a switch in memory, and it can be up or down. It can be a 1 or a 0. So how can I write the number 7 when I can only write a 1 or a 0? Because here's what a number would looks like in the computer. 1, 0, 1, 1, 0. Now that's not 10,110. That's just a series of switches. Up, down, down, up, down. Okay? So if my switches are up, down, down, what does that mean? And the answer is, the computer scientists came up with a very interesting trick. They said, you know how we said a moment ago that you can write numbers, and we could say that this is in a normal number, that in a normal number such as 1,237, we said this is the 10 to the first position, and the 10 to the second position, and the 10 to the third position, and the 10 to the fourth position, right? Well, in the case of our binary number, in the case of our up-down switches, 1 and 0, we can't write 10 because it's not 10. We only have two possibilities, 0 and 1. So this is a binary number. The word they use is binary. And binary means 2. Okay? So it only has two possibilities, 0 or 1. So here, the first position here, we can write this first position, and we can say that it is 2 the first, 2 the second, 2 the third.
Every other one you add another 2.
It's the same thing, 2 to the fourth and 2 to the fifth. Okay? And so now, what this means, what this 10110 is, 0 times 2, of course, is 0. 2 times 1 is 2, etc. So here we have 4, 5, 6, 32 plus 6 is 38. So this number equals 38 in decimal numbers. But in a binary number, the computer recognizes it as 10110. Now, when we were talking about networking yesterday, I made an interesting statement. I don't know if you understood it at the time. I said the highest number for an IP address, which is 4 numbers. So our IP address, I said, was 198.127.1.1. Okay? I said these numbers could be from up to 255. Why is it up to 255? And the answer is because it's 8 of these binary positions. I only wrote 5 of them here, but it's 8 of these. So if I add 2 more, black pen, if I add 2 more, 1, 1, now I have a, 1 more, right? 1, 2, 3, 4, 5, 6, 7, 8. Now I have an 8 position number, and these 8 positions together is 2 to the 8th power, and 2 to the 8th power equals 256. So any number that I use 8 positions for can be 0 to 255, or 2 to the 8th power. 2 times 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 2. And we have a special name for this that you may have heard in computers very frequently. We call this a byte. 8 of these computer positions is a byte, B-Y-T-E. So when you hear computers, you will hear this very frequently, although it's mixed in other numbers. You hear this term right here, and we say we have a byte, which, as I said, is made up of 8 positions, 1, 2, 3, 4, 5, 6, 7, 8. And by the way, each one of these positions is called a bit. And you may have heard the term K, or kilobytes. And kilo is a prefix which means 1,000. So kilobytes is 1,000 bytes. Or you have heard the term megabytes. Megabytes, which means 1 million bytes. Mega is the computer term for million. Or you've heard most frequently gigabytes. And gigabytes are billion. And so it's another 1 billion of these bytes.
And
there's terabytes, which is our next 3 zeros, and so on and so on. After terabytes, there's actually petabytes, and there's exabytes, and there's more names as they add another 1,000 of the groupings. But it all starts with just a byte. And what's a byte? A byte is 8 bits, and each bit is just a binary switch up or down. And that's computer memory. And that's the end of this lesson. And in the next lesson, we'll discuss how the computer reads the memory, what a computer does when it starts up to start running a program.
since